Okay, good afternoon, everyone. Welcome to the last of the breakout sessions of this first... Oh, I don't have to introduce myself. Now I'm not the invisible or the nameless moderator. So my name's Steve Phillips. I'm the Secretary General of the Conference of European Directors of Roads, and I'm the odd man out here because I'm the one not from the telecoms area, etc., etc. So you are at this one of these final breakout sessions. And in case you're in the wrong room, I hope you're not in the wrong room, this is Digital IT Infrastructure and Connectivity, which I will say this session will bring together various stakeholders from telecom operators and industry. The focus will be on the current activities and challenges related to digital IT infrastructure to support the deployment of connected and automated vehicles. So some of the issues we will talk about will be the different technologies, ITS G5, LTE V2X, LTE Advanced, 5G, and referring to the challenges posed by the requirements for CAD in terms of safety, latency, reliability, localization, etc. And then I'll be pressing the panelists and also taking into account the different deployment phases and the timelines for connected and automated services. So with that, I want to introduce our first speaker of this afternoon, which is Dr. Håkan Andersson from Ericsson, who will be presenting the Ericsson view. So Håkan, please.
Okay, now it's working. Thank you. Technology. I'm very happy to be here and to present this. And I took this actually title quite literally. So it's a little bit technical presentation, but showing a little bit on what we're working from Ericsson. And this discussion on connectivity, of course, it makes an Ericsson person happy at heart because that is our core business, on connecting things. When we have talked over these 2 days, I think we have talked quite a lot of different usage of the connectivity. Talked both for safety purposes, the collaborative ITS solutions, and what technologies we can use there to support it. But I think we have also talked quite a lot about the value of more generalized connectivity, connectivity to cloud networks, analytics done in there, and the value that can bring also from, sort of say, a commercial drive of deploying these solutions. So what I'm going to do is talk a little bit on the connectivity solutions we see from Ericsson supporting both of these ones. Because I think when we talk connectivity, it's valuable if we can use kind of a unified technology scheme. So we don't need to invest in parallel path in technology. And also if we can utilize investments already done in the industry. That will, of course, reduce the cost that any stakeholder, including the public parts, need to fund for these investments. And it will also, I think, bring a commercial drive into adopting these technology into the cars, which is beneficial when it comes to take-up rates. So if you look at these slides, this is a very simple one. I didn't have Amsterdam in mind. I didn't have the time to draw all the cars. So I have a few cars only here. Not even Stockholm. But anyhow, it gives the general scheme of it all. Quite a lot we talk, of course, about direct links. I mean, car to person, or vehicle to person, vehicle to infrastructure. And that is one part of the puzzle, I would say, and one that we often tend to discuss. When we look at cellular technologies, we tend to sometimes have forgotten or misunderstood that in LTE, using LTE for this and using the standard that has already been done now, by using cellular technology, we don't necessarily need to use cellular networks. So the direct links using cellular technology will actually work without any coverage or without any operator interaction. It works just automatically between the different vehicles or infrastructure of persons if they are equipped with this technology. There are some cases. So first, there might be that the take-up rate is not that big. So there are other ways of communicating. For example, vehicle to person. I think most persons do carry smartphones. I don't think they are connected yet with a direct mode. But by an indirect mode, you can actually start adding safety functions, utilizing indirect links between the car and the smartphone. It could also be used in the car. If you're looking at a car, not all might have modems directly. It has a take-up rate. It might be taking some years to get there. But you can have an applications on your smartphone that also gets these messages. It's a collision ahead, it's a slippery road ahead, so that you can start adding that value also to cars not yet equipped with the modems. And then there is another fairly trivial part. Sometimes there are some distances between the cars, and if one car comes in a slippery road and is dependent on communicating that to the next car, that it is a fairly short distance to that car. It might be that the next car that comes is too far away. He never gets the message. So you have yet another car getting into the slippery road, and a third car, then a fourth row, and it might be piling up that accident area. So by indirect link, you also extend the coverage of road safety warnings to, so to say, longer reach, which cannot be utilized by the direct mode. So these are, I would say, two quite complementary solutions for the both purpose, vehicle to X type of communication. But then I think we have this last part, which has been discussed quite a lot, on the value of connecting information from the cars into some analytics. And there will not one, so to say, analytics cloud servicing all need. I think each car OEM will probably have their own analytics part because they understand the sensor data from their car better than anybody else. And that way we can also start adding safety functions that doesn't necessarily need to wait for a standard how a message should be compiled. A car manufacturer would probably know how to read sensor data from the car and deduce that this is something wrong with the road or there is a pothole or something. And then by interacting to road authorities, they can convey that message by doing their own analysis and then transferring that information to road authorities. And on top of that one, of course, there is a lot of commercial players that might have a use of either transmitting entertainment, navigation support to the car, or also if there are, so to say, acceptance from subscribers utilizing some of the data that you can deduce from the car. But I think most of it will probably go to the car OEMs, and they will be the best one understanding how the car behaves. So this, I would say, pictures a more complete technology solution under one technology investment that can service the full range of different use cases. Then a little bit of summary. As I said, it's already been released. One misunderstanding is that it needs a cellular operator for the direct mode. It does not. It works by its own. You can add an operator to further improve the capacity, but it's not necessarily, which means that it works also across borders. You don't need to think of roaming agreements between operators to have the direct mode working. And then also I think one thing which we tend to forget sometimes, I mean, we don't call cellular technology for mobile technology for nothing. This technology was actually done to optimize in a mobile high-speed environment. So it's from start a design that takes into account speeds that could be in excess of 500 kilometers if you are meeting traffic. So it's a technology which actually is optimized for, I would say, automotive use cases. Then to sum up a little bit on some activities, and some of this was touched already this morning by the Swedish minister representative. Some of the activities we are doing. Nordic Way, for example, is a common Nordic. It's between Finland, Sweden, Norway, and Denmark, where we are using, so to say, we are demonstrating roaming of ITS services cross-border to show that there are solutions to make sure it ends up in the correct, so to say, road authorities, even if car comes from other countries. We are doing also quite a lot of activities here in Germany. One is what we call 5G connected mobility. We have a stretch on A9 together with some operators, road authorities, and also universities. Convex is one which we are demonstrating more particularly, the LTV release 14 together with Audi and Qualcomm. And then we have a number of, I would say, 5G activities. One is in Seoul in Korea, where we have connected BMWs in their driving center, and we are driving as fast as we can on those roads. There we can drive quite fast since it's not a public road. And we are demonstrating really the performance of 5G in that environment. And then we have some concept trials in our 5G network in Stockholm. One which I think is quite interesting and which we demonstrated also in Barcelona, and this is, so say, is it fully autonomous or is it autonomous at time and you can have interaction from a driver remotely? And I think we had an example yesterday about the traffic in Amsterdam where the Google car would cry because in some situation the programming might not take it out. So we have seen a concept where you have public transport that could be 90% of its time autonomously driving. But if it comes into a tricky situation where you actually need a person to interpret the rules a little bit more flexible, you can actually take over remotely and drive that public transport bus out of that tricky situation and then let it on itself. And that way you can have, for example, one driver managing 10, 20 buses. So you get autonomous, but you also handle the problems you can end up in a real city environment. So that was my 10 minutes, I think. So a little bit technology parts, but as I said, that was the title. So I took it literally. Thank you.
Well, thank you very much, Hakan. That was 9 minutes, so no latency in that presentation. That's great. So I've already explained to the panelists, and I'll explain to you, we'll take the questions at the end. That's mainly to keep all these guys engaged, so they have to wait for their questions at the end rather than running off. No, I joke. No, this is going to be a panel discussion, and we'll run through all the 4 presentations, and then we'll hopefully have plenty of time for a good discussion between all of you. So, without any further ado, I want to introduce our next speaker. Oops. We have to be careful with the. We can't all press the buttons at the same time. So, if I can introduce, Refi Turgul, and I did get this right at lunchtime. Gunnar.
Right.
Gunnar, close.
Right.
From CAPS, and he will be presenting the CAPS view. ITS G5 makes V2X for CITS happen. So, please.
Thank you, Steve. Good afternoon, everybody. So I want to complement what Hakan started to tell us why we are complementary and why ITS G5 makes CITS happen. ITS G5 makes V2X for CITS happen because it provides the communication technology for vehicle, and vehicle infrastructure and vice versa. The objective is to improve safety, efficiency, and mobility, where I want to underline the emphasis on safety. I am the opinion that every communication technology has its strengths and weaknesses, and the technology we are talking about, like ITS G5 and WAVE in US, has its strengths on safety. There are also efficiency and mobility aspects, where these aspects may be carried out by complementary technologies in a better way. And this technology especially supports autonomous driving, which is a future objective where the automotive and the community is working on. Why is ITS G5 suitable for cooperative ITS? Because it delivers us efficient communication. It utilizes 10 megahertz communication channels, where newer technologies were communicated, they are higher speed and higher throughput. The question is of efficiency. So ITS G5 uses much less frequency band. It's zero latency. As soon as you get your information over the ether, over the air, it is received and can be processed. There is nothing intermediate. It is to all relevant traffic users simultaneously, which means it's broadcast. This is one to many. We use simple and short data packets, which makes the technology very robust. In addition to that, in communication, of course, security is a very important aspect, where this technology delivers authenticity. So we know that the supplier of the information is trusted. It provides integrity, that we know the content of the information is correct, is not manipulated or corrupted, and it provides pseudonymity, which means the provider of the information is anonymous. We cannot track. But first of all, this technology is available. So we have frequency band harmonized and allocated. This is not only valid for Europe, this is also valid for US, for Australia, and many reference countries we had from the speakers heard before. Frequency band is non-licensed, so it is dedicated to ITS, cooperative ITS, so this doesn't cause additional cost to the user. It is an open technology based on international standards, so it is open to everybody. There are many suppliers and operators to support it. The standards are finalized. It's mature and available based on extensive experience and pilots. It's an international technology and standard, so we standardize it in Europe and in US, and the standards are very equal. From the use case application perspective, they are fully equal. There is a security framework and interoperability running on EC level. It is independent of network and infrastructure. And the deployment already started, actually. We heard in the morning session from Theodore. It is on production level, so companies producing it. Recently, General Motors announced again, after its 2014 announcement during the ITS World Congress, that they are deploying end of this year. Some European manufacturers are deploying 2019, obviously. And the technology is open for evolution, and complementary technologies like LTE, cellular V2X, 5G, whatsoever. It was also presented by Theodore in the morning in his session that communication technology is going to one to the other. Let's imagine our mobile phone. Can you consider it? We have LTE today in it. Can you consider it without wireless LAN in it? Would you use it without wireless LAN? I think no. So every communication technology has its strengths for the use you are looking for. Thank you for your attention.
Thank you very much. Again, another very, very timely and concise presentation. Thank you very much for that. So now we move on to Theodore. Some of you heard him speak this morning. Actually, pretty much the same slides, so don't go to sleep, because he's promised us that he will say different things. So actually count this morning's presentation a little taster, so you'll know what's coming next, but Theodore will surprise you with some of his comments on what's going to be the content of his slides. So Theodore Beberzan, yeah, from... We're trying to coordinate the microphones here. The handover is not very good. Anyway, so someone in the audience, please help us with this. I've got all the telecoms guys on the panel, and it's not helping me. Anyway, Theodore Beberzan from Volkswagen, again, will be presenting CITS and automated driving.
Yes, so basically, as already said, most of the slides have been already shown today in the morning session, and that's why now I would like to start on this slide and basically come to the discussion. I think that the session in the beginning was more focused on communication technology, and that's exactly the reason why I thought it's very good to put this kind of a slide here to see how our view looks like as a car manufacturer. And I think the analogy with the smartphone is also a very good one, because basically we have in our smartphones today, and also in the communication boxes, for example, we have at home, different communication technologies. And we see an evolution of the cellular technologies. We have also inside different models of the Volkswagen Group moving from 2G, 3G, and 4G. And also, in addition to the cellular communication technologies, we are also having other communication technologies like the ones based on IEEE 802.11. And these communication technologies either directly in the same communication unit or in, let's say, used for infotainment functions, it's already present there in the car. It's nothing new. And basically, based on this common base, we have the next evolution step, which will be happening in the next years, is to put the 11P there. And basically, we think that 11P is the technology which can help us support the road safety out there. And as already mentioned, there was extensive work, standardization work, harmonization work done on different parts of this world. And we think the technology matches the requirements we have for supporting road safety. Of course, the technology, we have also to say the technology was developed several years ago, and there is always room for improvement. But when looking into the future, there are also points we see that can be improved. It's the same evolution we see at the cellular communication. It's the same evolution we'll probably see on the 11P side. And more use cases will be made available. I think one important message from the slide is to say that there is no one technology which can match all the requirements. We'll always have a communication, and at least for us as a global manufacturer, we see there are markets where we probably have to use different technologies for supporting the same use cases. And I think the cellular V2X and ITS G5, it's one of these examples. It might be there some other markets which don't have, which haven't invested already in ITS G5 might decide to use some other technology for the direct communication, like China, for example. But that's something for the future. We'll have to see how the development goes. In any situation, whatever technology we're going to put there, it's going to be there for a number of years. And I think it's also been seen what the US government is doing in this direction. When looking, they are planning for decades on how to deploy different services on top of different technologies. So coming back to the technology evolution, and I think that was on the points we were asked how does the future look like. And basically that's what I like to show into the next slides, or shown already. We see for the cellular communication, we're going to have a migration towards 5G. There is already an announcement that different telecom operators will power down the existing 3G networks and replace them with 5G. And that basically makes us, as a car manufacturer, puts us in a situation that the 3G cars, which are already on the market, will not be able to be connected anymore. And that's why the step towards migrating towards 5G, it's also based on the necessity we have there. But we try to use 5G, or we're going to use 5G not just to do, let's say, more of the same, because that's one of the ideas. Let's do another generation. We'll have more data rate, shorter latency, but basically what we are looking towards at 5G is to enable new types of services and to enable new features to be provided. And we are looking towards, in addition for having the vehicles better connected with shorter latencies, with more available data rates, but more putting the focus on the user. I already mentioned this in the morning that a new set of use cases will be available there on the market. When looking at the next years or the next decades, we'll have automatic driving cars which will take more and more slices of the already existing market actors there. For example, the car sharing will be much widely spread, also automatic driving, let's say level 5 automatic driving, where there is no driver which can take over. So it's what we call it a robo-taxi, where basically you'll get some vehicle which will pick you up from home and bring you somewhere else. And for all of these vehicles will all need connectivity. And I've already mentioned several of the use cases in the morning. I think what's more important here is the requirements this will have. And basically that's the part I would like to spend a little more time on, saying what kind of technical requirements we'll have on 5G in order to enable these new use cases. And I think predictability is going to be one of the most important ones, at least from our part, because when driving around now, today, regardless of what technology we have there, it's always a best effort. So we don't really get any guarantees how the connectivity will look like in the 5 seconds, 30 seconds, or 5 minutes. And basically, when we want to provide, for example, automatic driving, when we have something like a teleoperated driving, you have an operator in a so-called command center driving a bus. I think it was the example shown by Ericsson. Actually, I really need to know when this bus is driving on the streets that I'll be able to still control the bus for the next 5 seconds or for the next 50 seconds. Otherwise, the bus will just move pretty slowly around, and I don't think automatic driving will make any fun to anybody. And that's why one of our requirements when looking towards 5G is to have this kind of predictability, to know how the network will look like, and basically when we have some requirements and we'll have some quality of service requirements there, to know how this quality of service requirements will be enforced there and for how much time. Of course, we'll have individual connectivity. We already discussed a little bit today about the topic of network slicing, but we see it's very promising, and one of the questions will be how this network slicing will be realized in the end. Because from now, from the point of view of today, when thinking about network slicing and having these vehicle-based services and user-based services, we'll probably have different network providers or network slices getting the data to and from the user and the vehicle. And probably most of them will be on the same hardware inside the car. So let's say virtually we'll have different connectivity or different vehicles from the connectivity point of view. And here, concepts like split billing will have to be extended in order to be able to accommodate, for example, the tariff the user have. And in the car sharing, when thinking that one car will be shared by 4, 5, 6 people a day, it might be that they have their connectivity services provided by a different provider, a different MNO, and all of them will have to be able to be integrated by us inside the vehicle, regardless of the mobile network operator Volkswagen will have a contract with. And this device virtualization and user virtualization combined with individualization and privacy will also play a role on how to define the future network slicing. And I think that's basically one of the future area where it's not just, let's say, the technology which is driving this, but also the service provisioning. Because we'll need new models, you'll need new interfaces to be able to configure, to start, to pay for these network slices. You might have different providers for them, and this is something still missing, and this is something we are hoping to get on the 5G. That's, I don't know how many minutes I have. I still have a couple of them. So basically, maybe to get a little more of information how the evolution path looks from our point of view on the 11P. As already said, on the day one, we're going to start in the next years with what's called the day one application, which are basically the application based on CAM and denim services. It's also very technical, but these are the ones we are looking, and a lot of, or several of the use cases will be enabled by these kind of services. But we think when we look on the street and we see, regardless of the communication technology, and we'll still have a lot of time to reach some high level of penetration. So you'll still have a lot of vehicles which are not connected there, regardless of the communication technology, and you'll also have pedestrians or bicycles or other users which might not be connected at all. And basically, that's why we are looking, and that's the activities which are currently happening at the standardization bodies and then the different research projects, where we look what kind of data can help us to see and detect these not connected road users. And basically, we are looking at this sensor data sharing, or collective perception, it's another name for it, where basically we say the vehicles or the infrastructure, the city infrastructure, which already has cameras and sensors, and they see the pedestrians, the bicycles, or the cars which are not connected, to get this data, aggregate it, and provide this list of objects or whatever they see to the other vehicles which can receive this information. And I think this is something which will definitely help us get a much better view around one vehicle, and let's say ease up the migration towards automatic driving. And this automatic driving then will also bring new data which would have to be shared. And this is the trajectories. Whenever a car is automatic driven, it constantly calculates trajectories and finds a way to navigate the traffic. And we think that these trajectories will not just be held inside the vehicle, but will also be made available to the other traffic users in order to enable them to see what are my plans, how my future looks like in 5 seconds, in 10 seconds, and they can act accordingly to them. Yes, I think that is basically it. Then I'll just slip to the thank you.
Okay.
Slide.
Thank you very much, Theodore. That was very interesting. Actually, I was particularly interested when you talked about the switching off of 3G. So it's not just the infrastructure owners, the road owners, who worry about legacy systems in their operations. It's the vehicle manufacturers as well. So that's something to bear in mind. Anyway, our final speaker. Our final presenter, shall I say, of this afternoon is Bob Banks from Vodafone, and he'll be presenting his take on the connected vehicle. Bob, press the...
Okay, thank you very much, Stephen. Welcome. Thank you, everybody. So my presentation is going to be a little bit lighter, so hopefully that is pleasing to at least some of you. So if we look at the connected vehicle, depending upon how you define it, you could claim that back in the late 70s, early 80s, when the two industries, the cellular industry and the automotive industries, effectively started their relationship, they delivered the first connected vehicle. And as you can see pictorially here, you've got the car phone. But obviously that evolved over time, and we've obviously had the move from where the phone is very much an in-vehicle device providing voice and text services for the occupants. We had a little bit of an issue, I suppose, perhaps in the early days of our relationship, where we started to cut holes in cars to put antennas, and we started sticking them to glass on the cars. But then, obviously, the hand portable phones came in, and the roles were a little bit reversed here, because we were then complaining to the car manufacturers that they were blocking the signal getting into all these handheld phones inside the cars. So it's been a good working relationship from start to finish, but obviously, as all good relationships, there's always a few problem points that we have to work around. As we move forward, and we're showing here the evolution of this connected car from the very early days, you've obviously now got the connectivity has been brought into the data services arena. So you've got the ability to do real-time navigation, get map updates, get live information about traffic conditions. You've got the ability to do streaming of videos. And then more recently, there's the inclusion of the Wi-Fi hotspot in the car, so that a number of devices can use the Wi-Fi hotspot that is then backhauled over the cellular network. So again, this is sort of another evolution of the connected car in terms of serving the people inside the car. I think what we've now got to is where we're delivering data services more for the benefit of the vehicle, or more for use by the vehicle, as opposed to be used by the people in the vehicle. So as it shows here, we've moved into the world of the car telematics. We've got the usage-based insurance, and we've got, for instance, stolen vehicle tracking and monitoring services. So these are all moving the connected car forward, and we've now reached a point where we need to take the next step. So this is a similar drawing to what Hakan showed in his presentation. So we're now into this where we're looking to connect vehicles to lots of different things, including themselves. So the Internet of Vehicles, perhaps, or moving the vehicle into the Internet of Things. And as has been said, there's various technologies that can be used for this, but we, as a cellular mobile operator, we're very much focused on the cellular technology to be used for this in terms of all the different connectivity and communication paths. So, as I said, it's a next step on this relationship between automotive and cellular. And to help us take that next step, there's been some new associations and alliances created. So the 5GAA, 5G Automotive Association, that was created back around September last year. That has very quickly taken on significant numbers of members. I believe it's in excess of 40 members now. So this is where it's the 5G, the cellular community and the automotive community come together. It's a worldwide organization, and they're looking very much at this connected, cooperative and automated driving. On the bottom there's the European Automotive and Telecommunications Association. This again has grown quite rapidly since it started last year. This has a slightly different scope, so it's very much focused just on the European geographic region, and it's also looking at other technologies than cellular. So here we have the 802.11p technology represented by various companies as well. So these two organizations have come together to try and help move these two industries along the path to the connected, cooperative and automated vehicle. So what are we actually doing in terms of getting our hands dirty? So in the UK, we have a test capability set up. This has been set up under a project called CITE, C-I-T-E. Again, it's a consortium of interested parties, both from the cellular communications industry, the 802.11p industry, automotive. There's road operator in there, Highways England, one of the key operators in the UK. And there's also academia, and it's Jaguar Land Rover is the car manufacturer in there. So again, we came together to generate a test and a trial capability of various technologies, the cellular and the 11p, and also various use cases. So this is a project that started in June 2016 and is scheduled and planned to run up until the end of December 2018. And this will be deployed in controlled environments as well as public environments on the public roads with the help of Highways England. So here we'll be getting very good knowledge and understanding and practice of making connected cars using the cellular technologies, using the 11p technologies, getting a lot of information and understanding to help identify how we move forward and make this all happen. If we move into mainland Europe now, my colleagues over in Vodafone Germany, they have a similar test set up on the A9. So again, they're working there with the German car manufacturers. This specific test setup for Vodafone in Germany is only a cellular setup. But again here, they're looking at testing the cellular connectivity, the use cases with different car manufacturers, with different tier 1 suppliers. So again, we're trying to get test capabilities and knowledge understanding from a broader spread in the industry. Finally, project-wise, this is one of the IATA project, as it stands today, called Concorda. This has been submitted for European funding. This consists of a number of test capabilities in different countries around Europe. And one of the key aspects of the IATA Concorda project is to look at the interoperability of these systems across the different countries. So obviously that's a key requirement for these systems as people drive across the country borders. So this is very much focused on looking at that interoperability and driving that forward in a way that ultimately it can be a common and consistent capability that's delivered into the cars and the vehicles. Finally, I'd like to just play you a video, which is something we did set up at Mobile World Congress earlier this year. So if we just play the first few seconds. Okay, thank you. So this was set up on one of the smaller tracks at the Barcelona race circuit, just outside of Barcelona. And we actually had 4 different use cases as defined in the ITS world, and they were all delivered using cellular technology. So we took one of the early drops of the R14 3GPP release that Hakan mentioned, and we developed in-vehicle and base station systems to actually deliver these 4 use cases using cellular. So this is effectively what the cellular can do now with the R14 specification in terms of the vehicle-to-vehicle, vehicle-to-infrastructure, and vehicle-to-network. So I'll let the video run. It's probably one of the only wet days in Barcelona, I think, this year, and we hit it. So yes, apologies for the cheesy grins. So this was a combination between Vodafone, Huawei, and Audi, the 3 companies that generated this capability. So this is a red traffic light. The car drives towards it. There is a communication which alerts the driver inside, both visually and audibly, and also passes the information back to the car behind, again, so that the car behind doesn't hit the car in front. The next use case is what we call see-through, as you saw on the initial pictures. So this is where the video from the white front car is shown on the dashboard of the cars behind. So that was all done over a cellular connection to enable the car behind to see what's happening in front of the car in front. So if that was a big lorry, then you'd be able to see more and possibly be able to overtake. Vulnerable pedestrian. So this is where a silly man on the side of the road, who's a colleague of mine, so I can call him a silly man on the side of the road, he steps out in front of a car, and again, there's that communication, and this again relates to the concept of having in the mobile phone that he had the ability to communicate with the car. And finally, the emergency brake warning. So the car in front brakes suddenly for whatever reason, and that information is passed back to the cars behind. And all of this is obviously still at the connected level at the moment, but you can obviously see how quick and easy it could be taken to an automated or an autonomous. So the car does the activity itself rather than the driver, as is happening here. Okay, thank you very much.
Okay. Thank you very much, Bob, and thank you for everyone for being so good at the timekeeping. I was just reflecting on the fact that you talked about the start of your relationship with the vehicle. How can I put this? Earlier on, Joost van Toom talked about the marriage now between telecoms and automotive, and I've been thinking, well, actually, the infrastructure. We've had telephones alongside of our roads for almost 100 years now. We've been working with the automotive, but we're not jealous. We're not jealous about this new marriage. No, I think it's all part of an enlargement of the family, and we should be working on this together. So with that, I have a few questions, but we now have half an hour for discussion. I hope you guys haven't fallen asleep and that you're ready to engage in a debate with these people here. They've presented slightly different views, some complementary, some maybe slightly not so. Are there any immediate questions that you want to throw at from the audience? Yes, Sir.
Could I ask your opinion concerning the wireless connectivity? To what extent is the robustness and the security of these connections an issue that still has to be addressed?
I think first of all, I think you have to design the system so it's not dependent on connectivity 100%. Because you might end up out of coverage. You might have a failure of the modem in the car also. So autonomous driving, I think, has also to depend on sensors. With the connectivity, I think we can do a much better job when it comes to comfort of the automotive driving and, so to say, potentially the speed you can go at. So I think with connectivity, you can deliver a better automated driving experience. But I think it has to work by itself. And that's why I said, even if I discussed cellular technology, even for the direct links, I said that would work without any cellular coverage, without any relation to cellular operator or connectivity to cellular base station. So that one is fully autonomous, working in a similar way like DSRC on 5.9 with 10 megahertz channel. But I would say you cannot build a system where everything would fall apart if you run out of cellular connectivity, so to say. But it can augment and enhance the experience, as well as deliver other services.
I was also thinking about malicious interventions, jamming, that type of thing.
That, I think, is something we have in common with any technology. And the layers above we tended to discuss the physical layer. On top of that one, the higher layers of the communication, we are more or less reusing the DSRC protocol for some of the authentication parts. On top of that one, you have a fairly strong authentication mechanism, I would say, in cellular by itself. But there, I think also this discussion this morning of how to make sure that also software in itself is designed tamper-proof, kind of. So there are layers of security. I think that's one actually quite interesting topic. I think we're moving away from firewall fencing and hoping that everything inside them will be protected by more looking at each individual component, each software component, each communication link, each hardware component is actually have safety mechanism by itself also. So even if you break a firewall, there should be other safety mechanism on top of it.
Theodore, can I ask you to answer that one? But also, I wanted to come back to the comment you made about quality of service, because I was thinking, how do we guarantee? So we've got this issue of reliability and external issues, but also the reliability of the service in terms of network density. What happens when we have a very, very congested network, and how can we guarantee that there is space for the safety essential messages to get through?
So maybe before answering the question is how we look at the automatic driving. And basically the automatic driving, it's designed how it is today now, the thinking that the car has to be able by itself to make a judgment. And basically the more information it gets, the better it can autonomously or automatically make a decision. And basically, this decision is based on information. It gets information from onboard sensors, which it knows it can trust up to a certain degree. And then comes information it gets over communication technologies like ITSG5, cellular communication, or some other type of communication. And basically, all of this information comes together and takes an influence on how the vehicle actually drives, or plans its trajectories around the traffic. And when, for example, some network is not available anymore due to some disruption or it may be overloaded, basically the vehicle will always, it's called the functional safety, what we call it, basically the vehicle will go back to again to a situation it can handle with the information it has. And basically that's the information it gets from the sensors. And when there is no information there, then it will basically not be able to take automatic decisions and will have to revert to a driver or go on the right side and wait to be towed away. Maybe the other question to ask about the connectivity, I think it was a very good answer here. We'll not have 100% connectivity. But basically what's important for us, we also don't need 100% connectivity, or at least my view is that we don't need 100% connectivity. It cannot be achieved 100%. What's really important for us is to know what is the connectivity, what's the level I get, because usually when I'm looking data and what I need some information from the network or from the communicating party telling me how the connectivity looks like. Now you're getting this information and you're getting, let's say, basically as you have it on the smartphone, something like you have 4 bullets, it's very well. And what's going to be interesting also for automatic driving to the future is to get a glimpse how the network, how the connectivity will look like, let's say in 5 seconds from now. Because as I said, depending on the service, if you are being driven around from some people in a in a command center, you'll really need to know if this connection is going to break down or not. And basically inside the car we know what to do when the connectivity breaks down. What's important is to know at the right time. If of course it can always happen that it just breaks down, and then you'll have to slow down and move on the right side if you cannot handle it by yourself.
Okay, thank you. Refi Tuggerl, you made a comment, you talked about the strengths and weaknesses, you talked about the need for the different technologies to work side by side and the complementarities, and you also talked about the security of ITS G5. How would you respond to that question?
I think in the dedicated link between in the cellular world is based on the means of security of the cellular world, and we defined in the V2E, V2X ITS G5 a new approach which is open, received by every node without intervention of any other node in the communication, and it is, as I said, authentic, integrated, so it is not corrupted, and it is anonymous, so it is not known by whom it is sent. So this is the major adjective to define the security for ITS G5, I would say.
For the rest of the panel, I mean, how much importance do you place on this, the anonymity aspect of it? Is that something you are worried about in terms of the services you're developing? Bob?
Yeah, just quick word on that. So yes, it is. I mean, I think we're very wary of keeping the privacy of information, privacy of data, anonymity, and obviously there's a legislation that we as a mobile network operator has to align with. So we do regard this as very high priority, that we need to make sure that what we deliver does maintain the security as well as the privacy and the anonymity.
Yeah, I agree with Bob there. I mean, I think that is something which is, I think also has a good history within the cellular world. I mean, typically it would require regulatory intervention to get all the data that is transmitted in the cellular network, which is not the case if you transmit it through Google or Facebook or things like that. So I think the privacy is probably something we are quite good at.
And that was not a plug for any particular companies. Okay. He had a question there, gentlemen. In the
Yeah, Johannes Springer from Deutsche Telekom. I think it's very well understood by the telecommunications industry that we need a concept for quality of service, for delivering back-end related quality of service, multimedia, broadband services, and so on. With regard to ITS G5 and 11P technology, who is in charge of guaranteeing quality for that communication path? What is your expectation with regard to that? Especially if we are comparing that to the upcoming cellular vehicle-to-X technology and communication channels. Thank you.
I think we have to separate two different schemes. One is the communication between the vehicles, the direct communication. So this is almost depending on the availability of the environment and resources, so the time capacity. And the system, at least for ITS G5, is designed in a way it is controlling its capacity by itself, that regulating overloading in the channel. The other scheme is from the vehicles to infrastructure and from the infrastructure to vehicles. There we may have, again, different setups. There are networks where the operator owns the network, so the roadsides will be directly in the network of the operator. So you can have dedicated connection schemes. There may be other cases where the operator doesn't own the network, so you use open networks. Then the situation may be comparable like cellular networks. But this is not where the delay or the latency happens, because the ITSG5 is always communicating direct. You can implement the applications directly on the roadside in the infrastructure, so you don't need necessarily go to the any traffic control management center to do decisions, but you may. And those kind of applications and use cases are not very much latency relevant. So this is why I said they are, for the technologies, complementary effects, where you can, you don't agree with me, perhaps you want to respond.
If you are talking about the use cases related to ITSG5, of course they are safety relevant and they are latency critical, I would assume. And also on the connectivity level, on the communication layer, there are a lot of scenarios can be simulated and maybe are also foreseen: overcrowded communication channels and so on, congested communication channels, where nobody guarantees in a direct communication mode that the message is delivered in time and delivered successfully. So the question is, with regard to DSRC or with regard to ITSG5, who guarantees quality of service if quality of service is needed?
Just one sentence. I think we consider as the quality of service the expected response. So if we talk about the robustness of a communication link, like a radio link, we agreed just in the discussion 15 minutes ago that a radio communication link can never be guaranteed if it is jeopardized, jammed, or whatsoever, irrelevant which technology you use.
Maybe to get a better understanding on how we look at the ITSG5. ITSG5, yes, it's a communication technology, but from our point of view, it functions like a sensor. So basically, it's a sensor in reverse. Basically, on a sensor like a radar or a camera, you send something out and you receive some response. And in the same way, the ITSG5, it's working for us. It's just that the other party sends by itself the information. And the quality of service, when looking about the ITSG5 use cases, like the one for safety, is how the channel management is done, the congestion control, and basically it's the physics behind it. A vehicle which is closer to me as a receiver will usually have a higher power level, and it will probably also in a congested scenario deliver me the information it sends. And basically this vehicle, it's for me, from a road safety perspective, the important one, and not another vehicle which is, let's say, in 200 meters away. And kind of the quality of service, it's already embedded in the system that the guys which are closer to me get a much better chance of being heard by me, and so I'm able to react to them, brake or do something, as the guys around them. So it's a very crude and simple and functioning system, very similar how the sensors work. The sensor, for example, a radar, it's doing in the same way. It can provide very good accuracy and detail at very close ranges. And as the range increases, it becomes more, the histories around the object, it's bad. And that's how the ITSG5, yes, it's a communication sensor, but the way we handle it inside the vehicle and what we do with the information it provides, it's handled like a sensor data. So basically, it's a high-definition sensor where the other party gives me size, speed, direction, and so on. And the closer it is to me, the higher the chances are that I'm receiving this information, because it's just under my nose.
I want to expand on this because, I understand, Theodore, you're thinking like a vehicle man. You're thinking individual vehicles. Now I want to raise this to a network level because as a traffic management operator, it's, okay, it's lots and lots and lots of individual vehicles. So we are looking for that quality of service, that guaranteed quality of service. So I'm looking at Ericsson and I'm looking at particularly at Vodafone. Will you be able to guarantee that level of service when we get to these higher levels of, not automation, but higher levels of connectivity? What will happen? Because if that falls down, then let's face it, we have Black Monday, Black Tuesday, or whatever it is, chaos out there on the network.
So I think as mobile network operators, we're quite used to delivering quality of service in a very large scale. So I think that's something that's part of the DNA, part of the capabilities that we can offer. I think, as Theodore said, though, that the failure in any communication is always going to, wireless communication is always going to be there. So the vehicles, I think the Armageddon situation that you perhaps portrayed there, hopefully won't happen. I think it very much depends upon how far some of this automation ultimately goes. And ultimately the connectivity, what it actually delivers into the vehicle. But I think generally quality of service is something that we could look at offering. We do offer it today. There's network slicing that I think was touched upon, is one way of looking at how we can deliver that. So it's nothing that is new to us, nothing that's fresh to us, nothing that worries us.
Nothing that worries you. Good.
I think it's like Bob's. We started even in telephony, they were designed for a certain level of quality of service. We had, it was signed with a certain outage or blocking percentage. So I think operators have a very, very good control on the service they deliver. And that I think is also very important because by them constantly analyzing the performance on the network and in the future performance per each slice, they can also provide that information to the automotive industry, that now you're getting very far out on an area where the radio distance is such that I cannot perhaps guarantee the 1 gigabit per second, but I will give you 1 megabit per second if you're happy. And then the automotive or the car can adjust accordingly. I think the operators tend to have a very good understanding on what they deliver and can share that.
But this is, it has been a very topical issue. How do you, in network traffic, how are you going to enable or justify giving priority to certain bits of data and not others? Are you going to switch off, the videos, the Netflix or whatever? Again, no plug intended. that's running to the vehicles, or how will you maintain that as a network operator, or indeed as a vehicle manufacturer? Are you going to build that? Are you going to build that system into your vehicles?
Maybe a quick answer. Yes, we are looking what data, because we also have one connection to the mobile network, and basically when you have concurrent systems which all take up the available data rate we get, and for example in rural areas there is the connectivity offered, it's, let's say, worse than what we have in the big cities, and then we have to do some prioritization. So basically, yes, the Netflix will not run in 4K, but it might only run in HD at that point in time. And the vehicle critical services, they are going to be anyway highly prioritized. So let's say the comfort services and what we also offer inside our cars, I think it was also shown here, where we basically allow users to connect their smartphone to the car and then through the car access the network, because to get the better connectivity, it's something we will probably have with a lower priority. It's the normal way to do it, and when there is no connectivity, then there is no connectivity. We cannot do it.
Just a comment, I think what Theodore said is quite important. Sometimes we talk slicing and we think it's a slice per industry, a slice for the vehicle industry. And I think that's simplifying it. A car is actually a generator of different type of traffic. So I think a car would probably have multiple slices. One is for the sensor data, which could be similar like a massive IoT, a lot of small bursts of data to be analyzed. One is the entertainment services would run on a similar like mobile broadband slice. And one is the critical information related to safety and automated driving, which would run on what we call a critical MTC type of slice. And in the slicing, you can actually handle those as they would look like totally independent separate networks, similar like you have a cloud service on a data center. You would spin up virtual machines which have a separation of concerns such that if one is overloaded, it's overloaded within its dimension. It doesn't affect the load on the other virtual machines. And with slicing, you can do the same in the network. So you create a virtual network with characteristics like it would be a purpose-built network, but is realized by software on the infrastructure that is already there. And of course, not only then for the separation of concern, actually from an investment point of view, you don't need to run out and retrofit a lot of equipment out in the network. You do this by software.
No, I don't think I've really got anything much more to add to that, to be quite honest, Steve.
That's a nice quick one. Right.
It was me.
That was you.
Yeah, I liked your Netflix example. I recommend you take your streaming mobile, latest version, go to a soccer game and watch the game on your mobile. You will watch 1 minute later what happens on the field. So if you miss some goal, you can look on your mobile, so there will be automatic repeat on that.
Okay, support for that in the audience. I want to, because I'm very confident. It's going off again. I'm not sure, but I'm pretty sure that there was no, there was no timescales that I saw, and I said at the beginning we were talking about timescales. I didn't see any by this date, so I'm challenging the panelists and maybe the audience as well. What timescales are we talking about? Because let's face it, a lot of people are scratching their heads at the moment, thinking, "Oh, do we hold off and wait for 5G, or do we push ahead because the real challenge is now?" What are the timescales? What are the maybe competitive issues between? Because we've largely portrayed this as, oh, everyone can carry on together and it'll all work fine together. Are there any conflicts between the different roadmaps? And I guess, who's going to pay for it? Sorry, a lot of questions there, but we're running out of time now and we have to get to these issues. Theodore, yeah?
So time schedule. So basically, the time schedule, you'll not get from me any years or products or names.
Okay, next one.
But basically, I think the question was already put out today, and some years like 2019 were already said by Claire in the morning and by some other people. And basically, when looking at and putting some deadline, when you want to deploy something in the next years, you have to take something which you already tested, which is already standardized, and which is already available. And I think it was also the approach taken by some of the field trials I've seen through the day-to-day, where they said, yes, let's take the ITSG5, we'll take LTE and something and look how the services look like. Of course, you can also wait for a couple of years, and from my understanding, we're looking at the cellular V2X, because we've been also looking at the technology which is going to be made, which I think it was now in March, finished the release 14, and which is going to be this year, at the beginning of next year, is going to be tested. We've seen already some of the planned test fields, and I would imagine that in a couple of years, maybe faster than it was for ITSG5, we also have a point where we say, yes, it's the time you can make some decision and look on it. The question is, when do you want to make this decision? And if the decision point, it's in the past tense already, then it was only one technology, or it is only one technology you can choose. We already seen Opel is already there. We already said that from our point of view, we also try to put it out there as soon as possible. So we already made some decision on how to handle the ITSG5. And of course, when we sit together in 2020 and there is a blank sheet of paper, then we can make again some decision. And there are some other manufacturers who haven't made any decision, and they have to make the decision by themselves when do they want to bring some product, some technology on the market. And also, maybe just another point is, the question is the timeline. It's about also speaking about 5G. So I know there are a lot of 5G test fields. The question is, what do we take as year when it's 5G there? It's when the first official 5Gs there, when you have 20 sites, when you have 100, when you have 1,000, when you have 95% coverage. So it's also not that easy to answer this question. My personal view is that we also see in the next years and probably in the next decade a pretty good mix when looking what 3GPP is doing also on the topic of 5G. My understanding is the LTE-based technologies are also going to be there for a pretty long time. And that's something which it's also very interesting for us. We heard already a vehicle has a lifetime around 15 years. And now I cannot put any vehicles with the 3G technology anymore because I know they are going to be only years. They are available in some parts of the world. And the same situation will be also for 5G and LTE and ITS-G5. We'll have to see how this looks like, but it's going to be a long period of time.
Can I just stop you there, because you talk about you're not feeling anything with 3G, but I think we heard this morning how Spain said it's finally got, 100% 3G on its network. I know there are some road operators out there now who say there are sections of their road network that don't have 3G. So if 3G is, are you just going to make a jump because, okay, it's never going to be there? And what are we going to be doing it with other technologies?
That's one of the problems. If you are still waiting for the next technology, you're not doing anything. So it's always going to be, let's say, like this ITS-G5, it's a technology developed, I don't know, 6-7 years ago. So basically, if we are doing today the technology, the communication technology evolved, and I would imagine that you'll do some stuff in a different way, in a better way. But also, from what I know in Norway, 3G is going to be switched off at the beginning of next decade or something like this. I think it was some announcement. That's the one I'm having in mind.
Norway, sorry, Norway I don't know about, so, being a Swede. So.
I know it was from Telenor, some announcement that they will switch out 3G, and also when discussing the topic of 5G, the indication we got from a lot of operators was that they are looking into re-harvesting the 3G frequencies for 5G.
Okay. Switching off FM. That's the big announcement they made at the beginning of the year. They want to be the first country to completely move to DAB. Anyway, Bob, did you want to?
Yeah, so just picking up on a few points that Theodore mentioned there. So yes, the R14 3GPP spec is completed, and we do expect to see trial products to feed into some of those test beds that I showed you towards the end of this year, with commercial product then coming out sort of by the first half of next year. But it is a little bit of a supply and demand issue here in terms of exactly what is required. So we could have the network capabilities to support the V2V, V2X, etc. out there, but obviously we're a business. We roll out what we feel we can make money from, what is going to be good overall. So I think it's a little bit of a chicken and egg supply and demand type of thing. I think what we can do, though, I believe, is to deliver quite a lot of perhaps some of the early implementations of some of these use cases, perhaps via the network. And I think, again, picking up on what Hakan said in one of these slides, until the cars have got this dedicated V2V capability, then it may be a case of we can deliver something more through a V2N to V to start to bring some of these services into reality, just delivering them in a slightly different way. Obviously, the latency associated with that would be somewhat different. No, I'm not going to put any numbers on that. But it still may be useful to start providing some of these capabilities through that means. So the ability to warn another car that a kilometre ahead there's something in the road and they should consider where they're going to position themselves on the lanes, that surely has got to be useful. And that is probably something that can quite easily go via the network. So as more and more cars get cellular connectivity in, then there's perhaps ways of delivering some of these things in the early days without necessarily having the V2V capability.
Any final comments? Because I want to make sure I'm off this stage before Catherine comes back in the room. Oh, is that
Yeah, just to pick up on the 5G, because I think this is also one thing which is quite different from previous generations. We have been a little bit, I would say, in previous generations, we've taken what we had, we multiply the capabilities by a factor of 10, so it's 10 times faster data rate, 10 times higher capacity, 10 times shorter latency. Then we come up with a new 4-letter acronym from FDMA, TDMA, OFDMA, CDMA, and then we're done. I think 5G is actually quite different. We have not come up with a new 4-letter acronym. It will, surprise, surprise, still be OFDM-based. And we are not seeing it as a kind of a replacement. So LTE, we are looking as part of a 5G solution. So are more, I would say, learned that it doesn't make sense to throw away the previous generation. There is quite a lot of momentum in that one. So there are a lot of things which is added on top of LTE to bring it into kind of a 5G solution, which will work with slicing as well. So it's much more gradual. And for example, narrowband IoT, which we just specified, we see that as part of a 5G component. So it's not like a technically heavy-side function to introduce 5G. It's more of a gradual slope, and suddenly we could put the 5G label on it, but it's not that different from the day before or the day after. I think that's the difference. And then a little bit on also longevity of technology. That, I think, backwards compatibility is something we are extremely good with in the cellular. Of course, if you turn off a network, that's one thing. But if you take a GSM phone from 1995 and use it on a GSM network today, it will still work, because we are developing functions in a backwards compatible way. And I think that's quite a good, so to say, legacy we have in our network, that we don't throw away old equipment. We're actually making them work, even though there has been tenth of releases in between. We still are doing the things in a backward compatible mode. So I think that's quite good.
Okay, one very, very quick.
I would like only to remind you about the session in the morning by Claire Dupré and Martin Böhm, C-ROADS. They very clearly defined the roadmap where we are going now. So the C-ROADS project is defined for the time frame 17-20. In around 18, the harmonization on European level for ITSG 5 will be done, they announced. And the next year, the LTE harmonization or complementary contribution to this communication will be added. So we have quite a vision and a roadmap for that, and I think the supplier industry, the politics, and the consumer industry and the operators will follow that.
Okay. Thank you very much. We have a vision, we have a roadmap, we have backwards compatibility. The future is rosy. Okay, thank you very much. I'm sorry we went a couple of minutes over the schedule, but I'm sure the next session will get us back on track. Thank you all very much. Thank you to the speakers.
Sit anywhere in the front row, fine. Wherever you like. No, wherever you like. Just to ask before everyone gets in, these were lost in one of the listening rooms? Mansholt? Has anyone lost cables? This is not show and tell. Oh gosh, this is your. Okay, did you know you'd lost this? Ha, voila. There you go. I'm glad. No? Oh, that's hilarious. Oh, that's hilarious. Okay, no. Do you want it? No. Okay, let's start again. Is anybody? No fake claims. Still holding these up for people coming in. Okay, if you can come in as quickly as possible, please, because I'm sure some people have planes to catch. In fact, who does have a plane to catch? Does anyone have a plane to catch? Ah, less than I thought. Train? Who's going back tomorrow, then? Ah. What's tonight, then? The Grand Place, the Mannequin Piss, Belgian beer and frites. Okay. You can come and join us, please. These belong to anybody who's just walked in the room? They were missing. This was missing from the listening room. No. Okay, I'll give that to you, and maybe just as the stragglers come in, you can ask. Thank you. Okay, can you get settled as quickly as possible, please? Thank you. Was productive, the sessions? Yes? Good? Okay, so I can go. Great. Thank you. All right. Thank you. Okay. Don't know if I can start. Okay, great. Doors are closing. So we are really on the home straight, all right? As I said at the outset of the day, and it's really great to see how many of you are still here, so thank you so very much. And it's also good to have a conference organised where actually you're released pretty early. Sometimes these go on even on the second day till about 5:45, as you probably are familiar. So it's nice to get out into the sunshine. So because you all dispersed in your various breakout sessions yesterday and today, and because one can never repeat the same top lines and issues often enough, let's have a recap and gather all of that intelligence in the next 45 minutes. So I'm going to invite each of the session moderators to come up here and join me just for 3 minutes of the top lines of what came out of your discussions, where you think things need to be going. And maybe I'll ask you a question. Don't worry, I won't terrify you. So obviously I'm not going to start with the guys who have just done these last three. I hope not. How about I start with shared and automated mobility services for our cities? Have we got that moderator here? Ah, that's the gentleman who checked with me from Vedicom how he should proceed. There you go. That's yours. I'll grab that and let's see where we get to. Thank you.
Thank you. So good afternoon. I've been asked to captures the most important key message from this breakout session one, the shared and automated mobility services in our cities. I think it was a very interesting session because we got the opportunity to get the viewpoint from local authorities, transport authorities, and public transport operators. So one who are in charge to develop the policies, to make the decision on investment for the future of urban mobility. So what was quite of interest is this session was not about what technology can deliver, but more about what we need to do and how we can make the best use of this technology to improve and to sustain urban mobility for all users. So there was already something to start from, all the activities dealing with shared mobility services and how we can take the best of the automation, this innovation coming from innovation to transform these shared mobility services in shared and automated mobility services. And I think one key statement that was made by all panelists was there is a clear need to fully integrate this new generation of services into the existing public transport system. So we need to complement the existing public transport system with these innovative services that cannot be delivered today with traditional vehicles. How we can make the best use of automated driving vehicles because we can provide better service flexibility and we can reduce operation cost. And when we talk about new services, we are talking about low-demand service, for example, night service or on-demand door-to-door or last-mile, first-mile for transit feeder. There was also a very strong position made by cities that if they have to choose, one option is they would prefer the shared automated vehicle scenario in order to better use the public space. So there was an interesting explanation about parking. But also they see it as the best way to mitigate risk of increased congestion that could be caused by private use of automated vehicles in city centers. Because private users, there was a clear statement made that what is considered today as time lost in traffic jam could be just extra time to do some extra work. There was also interesting lessons learned from automated public transport services already done in Europe. And one key finding was there is a very important need to check the user acceptance. And there was also a very interesting findings about the importance of human presence in the automated vehicle. So there was this explanation that at the end, driver is doing more than just driving. So this is why we need to keep this trust for the end users, how they will perceive a vehicle without anyone in the vehicle. And also there is a need also to learn from these trials, demonstration on how to build new services, but also how to build the right new business models. So last, what could be the next steps? I think there was a clear interest from these local authorities, public transport operators to do more in terms of developing knowledge through more tests, more demonstrations of shared and automated mobility services. So they want to test these services in different environments. They want to use different type of automated vehicles. That could be bus, pods, shuttle, cars, whatever. And also they want to foster cooperation between public and private sectors, but also between demand and supply actors.
Okay, perfect. And probably just a very simple, can you hear that? Yeah? Can you hear sort of a very simple soft question, I would say, which is, in all of that discussion, is there a sense of excitement and we can do this, that kind of level? Is there a voice of caution, a voice of challenge? Does it feel something rather overly challenging? What was the sort of the mood in a literally a couple of sentences nutshell, would you say?
I think from the perspective of the panelists we had, I think it was quite enthusiastic. I think they see the opportunities, also are quite knowledgeable about the potential threat. So I think they have a quite good knowledge, and I think there is a need to develop further this knowledge, but also to share this knowledge with more cities. We need to get more feedbacks to develop a clear strategy all over Europe.
All right, thank you so very much.
You're welcome.
Thank you. Round of applause, please, for this gentleman. Thank you very much. You kicked us off splendidly there. You were very tall. I can bring this down a bit now. It's rare. Normally in high heels, I'm right up here, but I'm bringing it down. So where is the moderator for physical and digital infrastructure? Thank you very much. He set the scene very well. He was very clear. I have no doubt you will be as clear. Thank you. So what did you hear? And in your session, what were the main top lines, and where do you think we might be going? Thank you.
Okay, thank you. Thank you. So I have tried to summarize here. We had 5 different presentations, and for each of them what they highlighted and what came up during the discussion. First of all, road operators. I think the message, one of the messages made was that for the road operators, the challenges come first. So there's a lot of challenges first, and the benefits come years later. So in a way, and managing the mixed traffic is likely the major challenge in the short term. Again, mostly linked to physical, but also to digital infrastructure. There was a discussion on whether we need to add more elements to the infrastructure, or whether we can leave out some elements of the existing infrastructure. And one of the answers was that the latter is only possible if there's no mixed traffic on that part of the infrastructure. We get the full benefits of automation only when we have the area or the road only restricted to automated vehicles. Then I know that some will not. I'm not going to say more white lines, because I say that there are some persons who will not be happy with that. But nevertheless, it was highlighted that good road markings and signage and well-marked shoulders could be much more important in the beginning than digital infrastructure, just to support the work of the in-vehicle sensors. And also that landmarks, roadside reflectors may also turn out to be important as well, especially to help in positioning the vehicle and give the support from the infrastructure side. Also, we discussed obviously maps and how the push is now towards pushing the boundary towards more real-time maps, and also how artificial intelligence can be used in developing the digital infrastructure in terms of interpretation of the sensor data that is used to collect data for the digital infrastructure. And last, I think it was highlighted how important it is to maintain a real-time electronic horizon for the automated vehicles. This can be done by utilizing data in the clouds and reliable hybrid communications with low latency, and not forgetting that we have to protect privacy and security of the data in all cases. So that's where the main points highlighted.
Thank you. And I think I pick up again because it was something that came in the sessions today about the road operators. You said that they see the challenges first and the benefits later, yes. And that road operators and roads really need to be in this conversation amongst the automotive and amongst the whole digital side of things. Would you say that comes out very strongly for you?
I think it was quite clear that this is a multi-stakeholder game, and we need the efforts of all of the stakeholders to make it possible and to make it safe and efficient.
Okay, thank you. Thank you so very much. Thank you. And then, where is the moderator for in-vehicle technology enabler? Thank you.
Thank you very much. So, in-vehicle technology enabler, starting from one question before, how was the mood? We can make it. So this was a positive mood, I think. And also taking from yesterday work from Clara de la Torre, the GRTD director, safety is a key element of our technology, and so this was very well understood. Some elements. First, technology has to put in a global architecture. And the architecture in vehicle has a long life, maybe 5 to 10 years. And we have also to consider that. And then is maybe divided in hardware. And first, maps were mentioned. And maps are not a traditional one, but the maps that have to be updated regularly on time with different layers of information and so on. And of course, sensors. Sensors, we have a lot of sensors today. We have up to 80 intelligence unit in modern car, in modern vehicle, modern trucks. So many sensors, but putting together information from different sensors. And also having redundancy of the same information is relevant. We mentioned software and all the communication aspects, starting from the vehicle to vehicle infrastructure communication, from the car-to-car consortium, but also going to the telecom automotive alliance. This is another key issue. What will be the final and the winning technology, we don't know. For sure, there are potential technology, probably for potential different application, and we see different solutions. Other word, cybersecurity, been mentioned a lot during these 2 days. Yes, it is a problem. When we connect whatever device together with another, there is this risk. But it's nothing more than something that is a part of the product development itself. It's part of the safety and security of the application. And we had, during a presentation by a small enterprise with a very innovative solution on that. This is not enough. We have to put all this information, this intelligence together. And then intelligent, artificial intelligence, machine learning, connected to the Internet of Things are things that come into the picture very heavily. The issue of validation, authorization, certification of the system came also on the table. So it's a matter how we can check the functionality, what the user is then perceiving, how the user is perceiving functionality and so on. This is an important topic, but again, is part of the process itself. Should not be is activity to be done, but it's not a critical one. At the end, affordability. Those CAD systems have to be affordable for the final user. And I would like to strengthen the final user. This is what all is about. They will decide what function they want, what is the gain that they have, what are the benefits that they will have, the impact on their life. So all that is important. But we have also identified a few systems that maybe the next or the very next year. Autonomous emergency braking, parking system. By the way, we had a very nice and good presentation outside yesterday evening, and I hope some of you had the chance to really sit down and make some tests of those vehicles. Other function, line keeping assistance, but I would like also to mention truck platooning. And some believe that truck platooning will be the killer application, not because it's going to kill anybody, we do hope, but it's just a name that is used in our domain. So let's use maybe another term, the winning application. And we do believe that this will put on the market the benefit of such systems.
Thank you. Thank you very much. Thank you. And interesting that you talked about the potential technologies for different applications. I think that echoes very much what the gentleman from Volkswagen was talking about earlier today. So, and you paved the way, indeed, for validation. So who is the moderator for vehicle validation, certification, roadworthiness testing? That's a long title, good grief. Another one not to say when you're drunk. Okay.
Thank you very much. I need the time just to... more time just to say the name, so thank you for this. Well, we had this nice session. I'd like to thank all the participants and moderation there. So it's full of challenge, all those things you just said a minute ago, especially for higher levels of automations. But we understand that it's also one of the building blocks behind the safe deployment of the systems. During the session, we had the chance to discuss the challenges and needs for testing on public roads. We had the experience of the Dutch license exemption procedure, but also a more practical approach, which was the European Truck Platoon Challenge, and we could discuss on what had been all these issues regarding different countries. We also had the presence of Euro NCAP. Regarding Euro NCAP, foresees that their position will be to inform the user about what are the automated driving functionalities that are in the market, that are in their vehicle. They are following an approach based on use cases in scenarios, but what they wanted to stress is the importance of how OEMs are implementing these functions. It's very different from one brand to the other, so this needs to be also taken into account. Regarding tools, methodologies, we had the presentation introduction of the Pegasus project. This German national project is dealing with the testing of higher levels of automation, and it's testing in all its stages. So we had a more in-depth view of introduction to what they are creating, which is a central database that is going to aggregate the information, scenarios, data that it's getting acquired or compiled from different tests. We also had the presence from Japan. Thank you very much. And we were introduced to what are their activities on field operational tests in 2017, 2019, and what their objectives behind. They want to not just test the technology, but also to improve user acceptance of this technology. This is important for them. But they also want to consider that roadworthiness testing must be in hand with impact assessment. They need to be together so cost-benefit risk can be assessed. But more summarizing and putting all together, what we could see during this session is that it's important to have cooperation in the field. Cooperation is a very important issue that needs to be tackled. Why this? We spoke about harmonization of regulation. This is something that it's being addressed, or at least have some kind of mutual recognition. And this is really important. We spoke about the European Truck Platoon Challenge, but it's important, and it's been spoken during these days, on cross-border testing. So this is something that needs to be addressed at some point. We also had the invitation to participate in the Japanese field operational tests. We are invited to go there and work with them, and also to their workshop in November 2017. So it's, again, one more year we're there. From the Euro NCAP side, they are also cooperating with other NCAPs, especially for active safety. It looks like with active safety, cooperation is being much more important for them. So also they introduced that they did see themselves as complementing what would be future regulations that could set up minimum performance for automated vehicles. So Euro NCAP could fill this gap for more advanced testing or more strict testing and so on. There was also discussion on how to we cooperate to develop cost-efficient validation. And again, this is very important for the industry, of course. And for this, for example, Pegasus is bringing an opportunity. We discussed with their experts on how do we expand this database, maybe to a component level, other stakeholders, countries. So this could be also a start for bigger cooperation and integration of different ways of information. And finally, as to finish out, it's been said before, but stakeholder cooperation is critical, it's very important. So we need to be together, the researchers, the industry, member states, traffic authorities, all the other stakeholders that together we need to work out to see how do we make this validation, verification, certification, roadworthiness testing of automated vehicles.
Thank you very much.
Thank you.
Thank you. Thank you. There we go. There was another place, so everybody's going to Japan now as well. It's like none of you are actually going to stay at home from the rest of this year, next year, 2019. There are so many places for you to go to talk about all this even further. So, who is on that great topic, big data, IoT, AI, deep learning? Gosh, I bet 75 minutes wasn't enough either for all of that. Thank you, sir.
Thank you. So we discussed, I think with many of you yesterday, big data, IoT, AI, and deep learning. I think we definitely concluded this is a very hot topic with very interesting speakers from Tom Luders from Hella, Peter Kolpa from IMEC, and Robert Baldassari from NEC. Starting with the first one, I think we really learned from Hella that if you have to validate, you could say, a simple sensor like a vision system It's really an awful amount of work to analyze all those frames. And the bad thing is, if you have a new camera system with an improved version, you have to do all the work again. So how do you deal with that? How can we reduce that enormous effort? That's, I think, a big challenge for this for a company who is really into the supplier business. Simulation will help. That was one of the conclusions, but it's only a part of the solution. And I think the key message that we draw together is that we need a reference. We need a code book which will really help in aligning between the different industries, because that was also one of the important conclusions. If you do this as a single supplier, single OEM, we all do this, but it will take too much time. We have to speed up. I think that was the biggest conclusion from Tom. Then we concluded with Peter. He shared with us that the view that we have and how much it takes from home to your office. The experience is different for different people. It's about how do you perceive it. And actually, if you really have to judge that, you need a lot of information. You have to share data. That was his key topic. And if you have to share data, how do you do this? What are the key challenges on this topic? Of course, everybody knows there's a legal and liability issue on this one. There's a technical one. But he learned us that also on a syntactic level and on a semantic level, we have quite some issues. From the syntactic perspective, we really need open standards. That's the basis to make this happen. So from a semantic point of view, we need linked data. We don't need to know exactly what's in the data, but we need to know how we can link it. It's the minimum basis for data sharing. And the big goal that he ended with was, how do we make sure that this knowledge that we create by sharing data is not only for the few, but is for the many? I think that's a task that we have all together. And then last but not least, presentation from Roberto Baldassari. He said, well, to really detect different objects, that's something what we already could do for, let's say, 5, 6 years ago. We already could do things better than the human eye. But the really true challenge lies in the detection of events. When is an event an event? How do they differentiate from each other? I think there's a big question for all of us, and how do we agree upon each other what we call an event? So it's all about end-to-end learning. That's the future. He mentioned the Autopilot project, one of the Horizon 2020 projects, which really will use IoT data to enable automation. He concluded his talk with one of the biggest challenges that we have is, of course, the testing. It will become a burden. That was also mentioned previously. Maybe we have to shift testing to training. That's it.
Thank you.
Thank you.
So, interesting. Maybe you should shift testing to training. You mentioned a code book for industry alignment. And yes, interesting. How do you perceive your commute? And a whole discussion around that. So, very interesting stuff. Delighted. I think there's a lady, another female moderator. Where is she? Am I right? Yay, I know. It's been you. Yes, I know. It's this whole positive discrimination rubbish. And look, human factors and user awareness. So the boys in the cars, and you're doing the human factor and user awareness. Okay.
Yeah.
There you go. Sorry,
there are boys doing human
sexist.
factors as well, by the way.
Thank you, Emma.
Thank you. Okay, so we had the great privilege of having 4 experienced researchers in our session, which was called Human Factors and User Awareness. We had 2 from academia and research industry, Natasha Merat and Satoshi Kitasaki, and we had 2 from industry, Trent Victor from Volvo Cars and Andreas Kienert from BMW Group. We also had a bit of an interaction with the audience. I don't know how much I have time, but I will try to draw the main conclusions. So there's a lot of talk about user acceptance, but I think it was highlighted that it's very important to have a user-centric approach when you design the system. So for me, as human factors at Volvo, it's also obvious, but it's something that's often forgotten. So it's a bit too late to look at acceptance when the systems are already on the market. You need to have the user involved. You also need to test the system in real or semi-real environments. We cannot be stuck in simulator and test facilities, but this is of course a safety issue, a regulation issue and so on. That was also highlighted. We need also iterated design process. There is a paradigm shift, I think not only in the human factors community, but also in general, from looking at how to minimize crashes and incidents by looking at secondary tasks and their influence. This is of course still very important, but now it's more, can we use automation as a distractor enabler? Will automation be the solution to distraction, etc.? What can we allow the driver to do while driving with certain systems in our trucks or cars? We also looked at the SAE levels of automation. I think that was highlighted as well, that it's often a bit misunderstood. I think it's also in this among us here. A level 5 system needs to be able to be driven anywhere where the human driver can drive. So it doesn't mean that it's just because you remove steering wheel and pedals, you have a level 5 system. It needs to be able to drive in all operational driving domains. And the driver is quite able. So there was some talk on that. And a manufacturer can say that this is level 2, 3, 4 function, but the user needs to be able to recognize that is it valuable to divide that when we do our research and development? Is it more important to just make sure that we know what to do as a driver and what the role of what we have in the car or truck? Am I in charge or is the system? Do I drive or do you? Who has the authority? And that brings a little bit into the research on takeover response time. This is a very hot topic. It was highlighted, the amount of publications in this area is huge. It's been rising the last couple of years. But it's important, it's not just about counting seconds, it's about looking at the quality. What happens when the driver is able to take over control? What does he or she do? What's the quality? Is she or he able to actually handle the situation when you go from automation to manual drive? And also we had a presentation by Satoshi on good ways to measure quality, driver state before, etc. We talked a bit about trust in automation, whether drivers will overtrust automation. We also talked, it's not just overtrust, it's undertrust. So there you have a bit of adoption. You might have too low adoption rate for system on the market today if you look at the benefits they actually bring. If we look at ACC and emergency braking system, for example, where there's been shown a real safety benefits. Driver training we mentioned as well. That was a bit of different opinions there. Is it okay to introduce driver training as a prerequisite to drive automated vehicles? That could be a bit dangerous to rely on that. Yeah, I have some more, but
no, finish. You've had
okay,
two more
I do
points.
two more.
Go on. Yeah.
We also talked about, it's been highlighted the last couple of years about not just looking at human factors and interaction design in vehicles, but of course also how to communicate to other road users outside, whether that's a good idea or not. That was also a bit of a discrepancy among the panelists as well as the audience. We had a bit of a voting there, so I think it was like a tie. Also, though, it was a strong belief from the human factors people in the room that automation will change the individual drivers after you get accustomed to driving with high level of automation in your cars or trucks, and this will change the complete traffic system, as was mentioned before. Thanks.
Thank you. Okay, so now we come to today. Who's up first? Digital IT infrastructure and connectivity. Ah, 'tis you. Okay.
I have to explain that. It's Emma. Okay. I have to explain because I was explaining how scared I was that she was going to come into the room and kick me out of her chair because she has dominated this stage for the last 2 days. Anyway, I'm here to talk about, what am I here to talk about? IT infrastructure and connectivity. So I guess from the start, 75 minutes was not long enough. We could have gone on for at least another hour, I think, because there was a lot of questions that I didn't have the time to answer, and I don't think the panelists or the audience had time to go into. It was a very interesting discussion, bringing together telecoms and automotive and others. I'd like to point out, coming from the road operator side, we've kind of maybe underemphasized that role, but I'd like to point out it's over 100 years since the first telephone box was installed alongside a road. So we have a very, very long relationship with both the telecoms suppliers and, of course, with the vehicles that run on our infrastructure, and I would like to square that circle, as it were, and bring that together in the activities that we take forward. Anyway, it was a very interesting discussion talking about the different phases, the different roadmaps, and how we can improve connectivity and the different services that connectivity, different uses that connectivity would be used for. Big emphasis there on, from the telecom side, or one of the issues was, the big value is going to be the data and how they're going to, it's not the direct services, it's all the data in the cloud and other things that they will be using in the future. One, I think, important clarification that came through, which was maybe a bit of a reassurance to me, and I guess to a lot of others. There's been a lot of talk about 5G. I guess I can start off by saying I kind of thought I'd drawn the short straw a bit, and that I was going to be in a panel where there was a lot of competition, but it wasn't quite as much as I thought. But there's been a lot of discussion about 5G, and I think maybe there are a lot of misnomers about 5G, and one thing that was made very, very clear is this is about cellular technology, not necessarily about cellular networks. Now, that makes a very, very big difference to the deployment, because as we know, deploying a network of 5G across Europe, well, maybe it will never happen. But the deployment of the technology may be rather more rapid. Nevertheless, the case was also made very, very clearly that we are dealing with a lot of different levels of technology here, and dealing with the legacy systems is as important for the automotive manufacturers as it is for the road operators, as it is indeed for the telecoms operators. And we need to move forward with all of these. And I like the comment from the automotive sector. We can't wait for the next technology in order to move forward. We have to use the tools we have now and move forward. I did try to press on what the, okay, I mean, that all sounds very great, but I was trying to press on, okay, but what are the challenges in that? Do we have competition between the different timelines? That didn't come out. There was, it was reiterated, okay, we have C roads, and that's very, very important. We have to push together with C roads, and we have to build on that. One issue that also came up was the issue of quality of service, which of course means a lot of things to a lot of different people. Ranging from the, I won't mention the provider, but let's say video streaming, movie streaming services in your car, right through to safety critical technologies, and how do we balance, what priority is given to the signals that come through, and how do we make sure that they're still there. So I think that's still, there's a lot of good ideas there. The telecoms operators seem quite clear they can deal with it. Let's perhaps go forward and see how that works and how we can overcome those challenges in the future. I think that's probably it in terms of the session. As I say, it was quite positive, I thought, in terms of its outcome. There is a lot of assurances that we can make things, backwardly compatible, that we can move forward with the new technologies, and let's just get on with it.
Sounds like a Nike slogan. Let's just get on with it. Okay, thank you very much. Thank you. Socioeconomic impact of CAD. Who is that? Thank you. You are the penultimate, my lovely, of this. Then we do have another speaker, but of this. Thank you, Satu.
Thanks. So we also had 75 minutes was clearly not enough for us. We had 4 presentations and a panel discussion. The first presentation was from US, and he set us a scene, showed the different impact areas, how automation will affect our lives, and also showed us the areas of uncertainty, how they relate to technology, policies, and user response. We saw a short overview of the US activities in this area. The second presentation was from Japan, and there we saw the safety impact of level 1 or 2 systems. And we saw how the non-monetary impacts are actually significant. and how there are a lot of impacts also for the non-users of the automated vehicles, so not just for the users of those cars. The third presentation was from the Netherlands, and there we learned that the main impacts of automation, or the main benefits of automation, come with the higher level of automation, so levels 3 or 4. With the first 2 levels, there are some impacts, but they are not as significant. Well, when we have the direct impacts, the short-term impacts on comfort, efficiency, safety, and costs, those will affect our lives so that it will make the car travel become more attractive, and it will affect our mode choice, the location choice, and urban and transport planning. And we saw several complicated pictures of the impact areas and how this whole field, what does it look like. And we got it clearly that there are hardly any research done in this field of these long-term, more indirect impacts of the automation, and that there are still several scientific challenges related to understand the whole field of socioeconomic impacts. The last presentation was related to socioeconomic impact assessment, and we saw that there are several existing tools to work with, and how sometimes the project doing this kind of assessment can be over-optimistic in the impacts, or maybe sometimes there is built-in pessimism which is causing bias. So probably the truth is somewhere between those two views, and that there are different dimensions on how you can do the socioeconomic assessment. It is hard to quantify all the benefits. There are a lot of related to, let's say, quality of life and this kind of thing. It's very hard to put a price on that, and therefore, at the time being, the time benefits dominate, but there are other benefits to be included later. The socioeconomic assessment is the last step. If you look at the FESTA-V, which is very common methodology for the field tests, that's the very last step, and therefore you need to be very economic in your socioeconomic assessment to do it in a short time frame. But it was very clear that it's not the rookie's job. You need expert to do that. We have, during these past 2 days, we have been asked to make our own future or create the future. And in order to do wise choices when making our future the way we like to do it, we need to understand the impact mechanisms that lie behind the automation of transport, and what kind of socioeconomic impacts do the different choices that we make, what kind of do they have. So there was a wish from the audience that this kind of socioeconomic impacts would have bigger focus in this event, and therefore next year we will aim for the plenary session. Thanks.
We will aim for the plenary session. Actually, I think next year, from what I hear, because 75 minutes hasn't been enough for anybody, even in plenary, I think it's 5 days in Barbados. It's just a thought I'll throw out there for this conference. Okay, so bringing up the rear, so to speak, we've got share economy, automation and electromobility. Met before, how delightful, thank you.
All right, so just 3-4 sentences about that very exciting session. We kind of went through, I did a little journey, if you want, through the value chain relating to this very big and broad topic that was extending the scope of this conference with putting more emphasis on 2 more points, one on electrification, so the link between automation and electrification, and then even going a step beyond just technology, also considering the usage concepts in the business models in shared economy and shared mobility. We learned very quickly from our panelists who were actually covering different steps in that value chain that there is indeed a lot of synergies at the technology level. So just consider that the architecture at the electronics level of an automated and electric vehicle has a lot of similarities. You can easily integrate that. But when we thought about it a little bit more, then we understood that this, in the end of the day, it shall be solutions for livable cities, as one of our panelists pointed out. And then we noticed that the degree of smartness that we need in the system goes beyond just technology. It's about, good usage models, efficient ways of transportation in the end. And we saw that we need to take quite some steps in order to make it really a good and new solution. So it's not just making the vehicle smaller. It's not just providing a car sharing system with it, because we always see there's a little bit of a backside then. Think of the shared car being maybe driven far more than the original one. Even so, there may be less of those cars. Still, there's the same kind amount of traffic, if not more, in the end. But it becomes interesting as soon as you extend the model of sharing even further and talk about shared rides, for example, ride sharing, or even new transportation systems that may be consisting out of shared combined pods and so on. There's also an option, as we understood, not just for passenger transport, but also for freight in all this. So we had, after a while, quite a good path towards the future with a clear vision that indeed would bring us forward. And of course, the question at some point came like, okay, but still, if I'm now one out of this 75% of the population that's a bit selfish, wants to sit in their own car, is there a solution for me as well? And yes, indeed, we also found one for that path that would probably go to reducing the size of the vehicle, making it lighter. If it's electric, if it's automated, you can easily do it, because maybe in the end of the day, it may be accident-free by definition. That would not require much of passive safety, would be clearly just active safety then, and you would have an extremely efficient car, and it would be long-range electric in the end. So 2 last comments on this. So we understood that taking these usage models into account and into the equation is essential to talk about or to come to a conclusion on a technology that is not just a revolution, but in the end of the day in a disruptive innovation. And the other is, well, there's connectivity everywhere, and I'm proud to say this as a coordinator of a project that is looking into connectivity in the context of automation, the SCOUT project. Yeah, that's it in a nutshell. Thank you.
Thank you very much. That's not me, so I'm going to remove that. Okay, it's always slightly disconcerting, even though you know who I am. Okay, so before I release you to grab your rides home, I'd like to introduce the lot. That's a tough slot you've got, I have to say, but nice. You can do the rallying cry at the end. The last speaker of the day, please will you give a very, very warm welcome to Paraskevi Michou, who is Deputy Secretary General at the European Commission. So I'm very interested to hear your closing words, and then I will conclude before everybody's released. Thank you so much. A warm round of applause, please. Nice to meet you.
Well, coming from Berlaymont, I thought that I will not find anybody here because I have learned from the colleagues that you had a very, very busy, interesting days, 2 days, and what I can add on this. Well, I think that I have some also to add. We have heard the results and wrapping up sessions from the 9 sessions that you had yesterday and today. Very many challenges, but I think that these challenges should give us the impetus and the momentum to drive this for the future. Ladies and gentlemen, good afternoon. I think that, or I hope at least that you have all read by now the white paper that the Commission has adopted very recently on the future of Europe. And the President has highlighted and outlined several scenarios for Europe, actually 5. These different scenarios imply different levels of engagement, cooperation, of unity, of harmonization, of cohesion, and definitely different results for the citizens. he wanted to show into this paper how big projects can have an impact on these different scenarios and how Europe can, and Europeans, can benefit from the different scenarios. One of his examples is the project of connected mobility, to demonstrate the added value of close cooperation that Europe promotes already for 60 years. A cooperation that has received a new boost in Rome in the Digital Day, when it was the celebration day and week of the 60 years of anniversary for Europe. As you have heard, I am sure, there was a letter of intent, a declaration by 29 countries that they have acknowledged that they will work together for connected and automated mobility, and that they have acknowledged that this is an emerging hot topic of the present for the future, bringing with it a lot of expectations, be it for business, be it for societal impacts and policy response. And all of this, I think you have debated, as I heard from the wrapping up session. The moment for me is to close this first ever European Conference on Connected and Automated Driving that you had these 2 days. I am very glad that this conference has been an extremely successful event to show what Europe already does, what it can do more or better, and what we all have to share. It generated a lot of interest. The interventions highlighted all the developments that we have already, and we are discussing also in the European Commission. I know that in member states we have also several developments and pilots. And I very much want to highlight also and welcome, and I would like to give special thanks to our international speakers for coming to Europe to share their views and experience on this area and on the way to improve international cooperation. Definitely is an area that we cannot work in an isolated way. We have to open it up. We have the benefit from the lessons that we learn each other. I also am sure, and I heard that you have discussed the legal and regulatory challenges, and Europe will be definitely and can act as a facilitator between the different legal systems. Currently, I know that in Germany, for example, maybe it was referenced in this conference, there is a law which is under the Bundestag for discussion about how it will go, how many legal issues will be implemented in this area. So, all in all, I would like to, and I have heard a lot, I would like only to finish by telling you what Europe's role and actions will do to support this deployment. We need to put this new technology development at the service of the European people. I heard a lot about the user, human, with concrete and tangible results that they feel in the daily life. The role of public authorities is to create the right conditions for safe deployment of self-driving cars. What is becoming clearer and clearer is that closer cooperation between member states, national demonstration projects, as well as closer cooperation with international partners is really crucial for the success of connected and automated mobility in Europe. Exchange of practices, exchange of expertise is also very important. We are now preparing a new mobility package to be delivered in 2 stages. one in May, 31st of May, and the other in November of 2017. The cooperative, connected and automated mobility will feature prominently in it. We need to identify the essential actions to ensure that the relevant policies, the legal framework and public support are in place for the rollout of highly automated and connected vehicles. Our ideas are based on, but are not limited only, to the result of ongoing initiatives, Commission initiatives, such as Gear 2030, and I'm sure you know that, the CITS platform of, or the high-level roundtable on connected and automated driving, as well as the results of the Horizon 2020 research. This also conference provided us also with a lot of thoughts and food for thoughts. Yesterday I had a meeting on this in the building opposite to here in Berlaymont, and we have discussed some of your introductory remarks in this conference, as we need to decide how we will put into this initiative in the planning for this year in the Commission. And we need all to join forces to develop and to test innovative technologies and to scale matters. This is also extremely important as well. We need to improve cross-border testing at different scales and cover the ground in as many willing member states as possible. Lessons learned from these trials, pilots, demonstrations should be shared and disseminated among member states, for instance, through the C-Roads platform. They should also guide our future actions towards the adaptation, possibly adaptations of legislation. The reflection is underway to put in place the building blocks for future recognition of approvals or authorizations. In the coming years, and I want to speak only by 2020, I don't want to prejudge the next, after 2020, MFF, we will provide through Horizon 2020 and through the Connected Europe Facility funds for such large-scale demos to test highly automated driving functions in complex environments and on the use of 5G technology for automated cars. We will also look at the more medium to long-term needs for research and innovation. The strategic transport research and innovation roadmaps, and I'm sure that Commissioner Moedas referred to that, will provide the long-term horizons for connected and automated mobility. Research and innovation activities and policies of all involved public and private players in Europe is in our thinking for the next 10-15 years. Ladies and gentlemen, this conference has brought you and us, all of you, together. Automotive and telecom industry, users, road operators, research centers, public transport operators, regulators, cities, research centers, universities, interested citizens. We hope this has allowed for contacts exchange and also created new cooperations, and it is creating the foundations for the next conference. Let me finish by giving a big thank all of you and asking for applause for the organizers, for the moderator, as I also see in all the sessions. It has been a great conference, and I would like to thank you all for your participation, your contributions yesterday, today, but more particularly for tomorrow. Let's stay connected in Europe, and let's drive ahead for the future. Thank you very much.
Thank you very much. So we are at the end. Oops. I've got about 30 seconds and I can let you go. We really are at the end of a very packed 2 days. Two things, your brains must be buzzing, but your bums must be pretty numb, I would say. So somewhere there and somewhere there. In case you missed anything important, it's good to get the word bum into. I've heard worse, and from politicians on my panel, so, oh yes, so I felt I could put the word bum in there. In case you missed anything important, all the slides, including, I hope, the summaries of the breakout sessions from the rapporteurs and a resume of the plenary sessions. They're going to be published online in about 7 to 10 days. I'm not going to put too much stress, so let's say 7 to 10 days. You need to really obviously keep your eyes on the CAD website. Coming up tomorrow are the side events organised by Catre and Scout, and those events will allow for even deeper discussions around the key issues. Let me also say, I know we've had thank yous, but really I think there has been a tremendous amount of work behind the scenes from the European Commission and all of the Directorates General involved, and for this tremendous beast of an event, the first one in Europe. So DG Move, DG Research, DG Connect, DG Grow, but interestingly there were so many others mentioned. Those are the big four on the large horse. There was a question about that yesterday. All four on the horse together, and they're all leading. Thank you also to the organisers Ertico, and also to VDI, VDE, very much, because I know there's been an awful amount of brains and content and energy, and poor David, I've been calling him over the weekend. Jesus, he was out shopping. Hello, could you give me that? Hello. So thank you very much to you, and thanks, of course, to our wonderful speakers, because it's really awful to have to condense all of that into such a short time. Thanks to you for sticking with it, my good people, and for asking so many questions. I'm sure there would have been loads more if we had the time, but it does certainly make my job easier. It's been an absolute delight to be amongst you and to learn much more about this incredibly fascinating, incredibly transversal, incredibly fast-moving area. I'm a great multiplier because I sort of come into this knowing much less, and I can now impress everybody at dinner parties, not least with the 100 years of the telephone box by the roads. I love all those little nuggets of wisdom. They're the kind of things that bring everybody to a stand. Oh, really? I'll use that. So I'm really pleased. Just let me say from my point of view, just because I am much more of the outsider, some of the really just literally key things I picked up that's very interesting. The absolute necessity for flexible legislation and not putting in place regulation that restricts innovation, and really choosing it. I think the gentleman from the States who said you need to sort of not get in too early but not put it in too late, because you need to learn from other people, but you don't want to get there too late, because then that brings another set of issues. And also to really do the research in the right areas. Choose where you don't need to be doing research. Testing in different settings, all sorts of settings, real-life settings. Very clear point came across: safety. There is no business case in safety. So I think that came across very, very clearly. And all of that whole discussion and the kind of data, the flow of data, how it gets reappropriated, how it gets used, absolutely fascinating. And affordability, that came up. And the gentleman who asked the two questions from the public authority point of view, of course, you know, keeping beneficiaries in there, it's a sort of strange word, beneficiaries, people, users, all of them, and really getting that co-creation at the front end, not as an add-on, and asking what the local authorities can do within it is absolutely critical. So thank you. My two things, when I heard about the truck platooning and the driverless trucks, who saw the film Duel by Steven Spielberg? I don't know, that's all I can think about when I hear that, and I just think when this comes about, we need to make an update of that. Hollywood needs to do a second Duel, and because the first one was scary enough, and that just popped into my head. And then I thought to myself as I was going to bed last night, what will happen to Formula One in this world? Has anybody thought about that? But I feel that needs to be on the agenda for a plenary discussion the next time round. And then, as I was speaking to a lovely German lady earlier, pervasive connectivity. I asked that be renamed, but maybe that's just me in that. Very interesting phrase. Yes. So, on that note, I wish you all very, very fruitful endeavours, a fabulous next few days, and an incredibly safe trip home. Thank you very much for joining me here.